Hey guys, welcome back to the channel. Today we'll be solving LeetCode 228 summary ranges. So we're given a sorted unique integer array called nums, and we want to make a range of these integers. So a range is basically any number from A to B inclusive. So it can be A or B or any number in between A or B. So in this example, a range would be these three numbers because they're consecutive. They're increasing by 1, 0, 1, 2, but we don't have a 3 in between 2 and 4. So this range ends here and it's from 0 to 2. Then this is a range over here and it ranges from 4 to 5. And this is also a range, but it's one number, so we're not going to put an arrow. We're just going to put that number alone. So this can be solved using a little trick where we have a start pointer and we basically just compare two numbers at every iteration, the current number and the number behind it, and we're just going to make sure that they're consecutive. We can solve this in linear time with constant extra space. So let's get into the explanation. We're going to initialize our start pointer to the beginning of the array, and we're going to initialize our I pointer to the second element in the array. But at every iteration, we're also going to calculate the previous element by indexing at I minus 1, and we're going to iterate through the entire array. If we ever encounter a point where two numbers are not consecutive, we're going to add to our result array a range, and we're going to reset our start pointer. So this can be better understood by going through this example. So our start pointer is at 0 and our I index is at 1. We're going to check is this 1 equal to this pointer minus 1, and it is. 1 minus 1 is equal to 0, and we're going to keep iterating. 2 minus 1 is equal to 1, so we're going to keep iterating. 4 minus 1 is not equal to 2, it's equal to 3. So we know that this is a range. So we're going to add to our result array. We're going to add that this ranges from 0 to 2. And then we're going to move this up and reset our start pointer to 4. And then we're going to keep iterating. So we're going to check, is 5 minus 1 equal to 4? It is. So we're going to keep iterating. And then we're going to check, is 7 minus 1 equal to 5? No, it's not. It's equal to 6. So this is a new range, and we can set it over here. So this ranges from 4 to 5. Then we're going to keep iterating, but notice we've reached the end of the array, and this gets set here. This gets set, start pointers over here, and we realize we can't go any further, but start is equal to our previous or our current iterator. It's equal, so we don't have to add an arrow because it just is one number, so we just add this to our array, and then we're done iterating. And the time complexity of this is going to be O of n, because worst case scenario, or every case, we're gonna have to iterate through the array, and our space complexity is gonna be constant because we're not actually storing anything. The only thing we're storing is our result array, and that doesn't count as extra space. So let's get into our code now. So we're going to start by initializing our result array to an empty array. And if if there's nothing in nums, if it's empty, we're just going to return the result array, right? Because we're just going to return an empty array. And then we're going to initialize our start pointer to the beginning of the array. And since we already got start, there's no point of iterating from the start of the array. Now we're actually going to start from the second index. So in Python, the range function takes 3 parameters: start, stop, and step. Step and start are optional. And if the current number that we're on is not equal to the previous number plus 1, then we're at a point where we could potentially have a new, or we will for sure have a new range. And then we're going to check, is the start the same as the end? And in this case, the end is I minus 1. So is the start the same as the end? And if it is, then it's just one number. So we can just append one number, which is the start. Or you could just do nums I minus 1 here. It doesn't really matter. Otherwise, we actually have a range where we're going to need an arrow. And in that case, we're going to append. And here we can use Python formatting. And we can use F for that. So we're going to have our start, and then we can have an arrow. And then our end is nums I minus 1. And after we've finished with this range, we're going to reset our start pointer to our current index like this. And after all of that, if we ever reach a point where we're at the end of the array, we're not actually going to be able to account for the last element, because we have our pointer technique is just like that. We can't account for the last element. So we're actually going to check the last element and see if it's equal to the start. So if it's not part of a range, and in the example that we did, it was that case where the last element was a range itself. It wasn't part of another range. Then we're simply just going to do what we did here. So we can just copy and paste this. And after all of this, we can just return our result. So this should work. Oh, wait, there's an error. I just caught that right now. This should be -1, and that should work. So the issue was that this actually had to be inside of this if statement. Let's see if our code runs. And it worked, and it's pretty efficient. This will run in linear time with constant extra space. Thanks for watching.